You know, we hear it all the time. GPUs are the engine of this whole AI revolution. But what does that really mean? What is actually happening inside that tiny chip that makes it so ridiculously powerful for artificial intelligence? I mean, seriously, how can one GPU be like 1,000 CPUs? It sounds like a total exaggeration, right? But here's the thing. When it comes to the specific kind of work AI does, it's pretty much true. And to get why, you kind of have to forget what you think you know about computer processors and look at them in a totally new way. So, to get to the bottom of this, we need to start with the fundamental difference between the two main characters in our story, the CPU and the GPU. It really is a tale of two completely different design philosophies. Okay, here is the absolute best way to think about it. Imagine your computer's CPU, its main brain, is like a brilliant, highly skilled chef. This chef can do it all, right? They can juggle a bunch of complex, different recipes at once with incredible speed and flexibility. A GPU, on the other hand, well, that's a massive factory floor, just packed with thousands of workers who are very, very good at doing just one simple task over and over and over again. So we've got the brilliant, versatile chef, and we've got the massive, repetitive factory. The next question is obvious. What kind of work is training an AI model really? Is it a job for that one-of-a-kind specialist, or is it a job for the assembly line? Well, here's the secret. At its absolute core, training a huge AI model isn't a series of complex, creative tasks. It's really just one mathematical operation. It's called matrix multiplication that's repeated millions, sometimes even billions of times. The entire job is defined by massive, brute force repetition. And that right there is why the GPU is the perfect tool for the job. Think about it. You wouldn't hire a world-famous chef just to butter a million slices of toast, would you? Of course not. You'd build a factory. And AI training needs that factory. The GPU is that factory. So how does this factory floor actually get so much done all at once? The secret sauce has a name, and it's called parallelism. And when we say parallelism, we mean it on a truly mind-boggling scale. We are not talking about a handful of workers here. A modern GPU is built to run thousands of tiny little computational threads at the exact same time. It's this sheer volume that creates that unbelievable performance gap you see in AI. This whole setup actually has a name. It's called SIMT, which stands for Single Instruction Multiple Threads. Just picture a factory foreman shouting one single command, like tighten that bolt, and instantly thousands of workers on the floor all do that exact same command on their own little part, all at once. That's SIMT. And for these super repetitive jobs, it is just unbelievably efficient. But here's where it gets even more clever. I mean, managing a factory with thousands of workers, that's a huge logistical nightmare, right? And the GPU has what is basically a magic trick to solve it. Think about it for a second. In any kind of workflow, there are delays. A worker might be waiting for a part to be delivered. On a chip, that's like waiting for data to be pulled from memory. So if all of your thousands of workers stop to wait at the same time, your entire factory just grinds to a halt. So how does the GPU make sure that never happens? The secret is this brilliant process called warp scheduling. See, the GPU groups its workers, the threads, into these little teams called warps. Now, if one team has to stop and wait for data, the GPU doesn't just let the whole assembly line go quiet. Nope. Instead, it instantly calls in a backup team that's all ready to go. Let's just walk through this. So a team of threads, a warp, is humming along, doing its job. But suddenly it needs data from memory, and it's forced to wait. On a normal chip, that's wasted time, but not here. The GPU scheduler instantly swaps that whole waiting team out, and in the very same moment, a backup team that already has its data is swapped right in and starts working. The result? It's the holy grail of efficiency, literally zero downtime. The most expensive, powerful parts of the chip are always busy. So when you put all these pieces together, you've got the factory floor of simple workers, you have that massively parallel SIMT architecture, and then you have this incredibly slick warp scheduling trick. That's when you get the true engine of modern AI. This relentless, non-stop efficiency is exactly why you hear about these tech companies building massive data centers with tens of thousands of GPUs. They aren't just buying raw speed. They're buying an architecture that is basically allergic to wasting time. It's all about ensuring their AI models get trained as fast as humanly possible. You know, this quote from our source material just says it all. GPUs aren't just fast. They are designed from the ground up with this core philosophy of maximum utilization. They are built to keep every single tiny worker busy every single microsecond. No wasted cycles, no downtime, just pure, nonstop computation. Ultimately, this highly specialized, massively parallel architecture is what unlocked the AI revolution we're all living through right now. And that leaves us with a pretty fascinating question to think about. If this is the engine that powers the AI of today, what kind of completely new architecture will we need to invent to power whatever comes next?